Hello and welcome to the fourth module, second part of McGill Academy's CAD tutorials. We're going to be covering more of our featuring tools in this particular video. So if you remember from last time, we experimented with everything in this sort of group right here. So extrusions, lofts, sweeps, etc. Now we're going to start getting into some of the cutting tools as well as some of the other aesthetically featuring tools. We're going to start with the extruded cut first. So what I've done here is I've created multiple extrusions and just a basic sketch based on what was left of Bob. So when I click the extruded cut button and I click on the sketch, you'll notice it gives me a preview. And it's automatically set to blind. And we can also change the direction of that. That's completely up to us. But you'll notice with the blind tool or the blind feature enabled, what we can do is just set any arbitrary distance to cut and it will automatically do that for us. So it's a pretty good tool to use in most situations. You don't really need a lot of precision when you're using that. But if you want to be more precise and just cut through everything that's already in the way, you can press the through all option. This is particularly cool. So as you can notice, if I press OK here, the through all option, what it does is it automatically detects everything in front of this sketch towards the direction you have selected, and it cuts it out. It deletes it. So that's pretty useful if you just don't want to, guess and check and put any redundant measurements. It's quite easy. So I'm going to edit this feature, go back, and also demonstrate the fact that we could draft. If you remember in our extrusion tutorial, we were able to taper our extrusions a little bit, and we can do the same with our cuts. Think of the two tools as almost being polar opposites of each other. To elaborate further on the through all tool, you could also press through all both, which, as the name insinuates, means that you cut through everything intersecting the sketch on both directions. So everything that the sketch would run into if you were to extrude it out that way or extrude it out the other way. Furthermore, you can press all of the up to tools as well. So the easiest one to use, in my opinion, would be up to surface, where if you just press any surface right here, boom, it automatically sticks to that as well. Almost the same effect as the blind tool and the through all tool. And yeah, so play around with those a little bit, see which ones you like the most, but the extruded cut tool will be quite useful in a lot of your ventures if you want to cut out a lot of the excess in your models.
Next up, we have the hole wizard tool. So synonymous to the extruded cut, it cuts into material. However, this is going to be particularly useful if you have any bolts or any screw holes that you're trying to fit into your model. So what you can do is select the type of hole. I'm going to select the counter bore hole. And essentially what we can do is we can set a position. So you press 3D sketch, and essentially you can plop this down anywhere you'd like. And we go back into type and make sure that the end condition is through all. So if you remember, through all means that this will go through any piece of material. As you can see, the dot goes to, it'll go through both of these extrusions. Furthermore, you can augment the fit. So this is particularly good if you have either very loose or very tight manufacturing sort of capabilities. So if you know your machine is not going to be entirely accurate, maybe loose would be your best fit. As well, you can change the standard type and size of your screw as well. So I've already selected a #00, but what I'm going to do is select a 3/8. So that's definitely more standard. Furthermore, you can see that we also have countersink values we can augment as well as the countersink angle. So if you're not familiar with countersink, essentially what that is sort of the outline of where your screw is going to be. So if you can imagine drilling into a big piece of wood, for instance, you're going to be using a wood screw. It's got a triangular tip, and the countersink is essentially that offset value. So it's, in this case, it's this angular component to this screw. So if I want to change our countersink diameter, we can do that. If we want to change the angle, we can do that. It automatically calculates everything for you, which is the beauty of it. Now, if you're done with this, you can just press OK. And what you'll notice is SolidWorks does all of the work for you. So it automatically sets a countersink hole for the head of your screw, and it also bores a hole in the size of your screw that you selected. Again, this hole wizard tool is going to be your best friend in a lot of your assignments.
For our next tool, we're going to be using the advanced hole tool. So this tool is particularly good if you have a screw that has multiple different features on it. So say it has a portion that's not threaded, and then it's followed by a portion that's threaded. This is the tool you want to use. So what I'm going to do is I'm going to select a near side as this prescribes. So we've set this top side. And what you could do is you could insert elements underneath. So think of this as like a jigsaw puzzle of sorts. So if we insert an element underneath, so this is a counter bore right here. We can either select a countersink, any type of option we prefer, but I'm going to select the counter bore. For our next element, I'm going to select a hole. So as you can see, we start off with a counter bore, and then as we progress further down, we have a hole. And if I insert another element underneath, you could also insert one above if you ever get stuck. I'm going to make that a straight tab. So if we zoom in here, this is placed at an arbitrary location, which will change later on, but it already selected what we want. So if I click on the counter bore, it's got the counter bore selected. If I select on the unthreaded portion, it's got that selected, etc. And we can change these bit by bit. So what I'm going to do is, I'm going to click size and say we want this to be 3/8. Furthermore, you click on your next element, so that's our hole, and I'm going to make that a 1/4 inch. So we find 1/4, and there we go. And what you can do here now is actually set how long you want this portion to be. So currently we have the unthreaded portion of our screw selected. I'm going to make this 1 inch long. And as you can see, it's been extended by 1 inch. Furthermore, we can click on our straight tap and set a size for that as well. I'm going to go, let's say 1/4 28. And now we have to set an end condition if this is going to be our last element. So you click this portion here, it's the end condition, and you press whatever you want, but I'm going to go with through all. So if you remember, through all pretty much dictates that this final element will go from its origin point all the way to the last model that it's going to come in contact with. Next, we have to set a position. So what I'm going to do is just set some random arbitrary position on here. You could click wherever you'd like and press OK. So if I exit this wireframe right here, you'll notice that it highlights the portions that are not threaded. So this is the unthreaded portion. And then this is the tapped portion underneath. So if we go through here, and go through here, you'll notice that everything is sized slightly differently. And this tool is very useful if you have to accommodate for any weird screws. Finally, what we're going to be talking about now is the threading tool. So what I've done is I've deleted all other remnants of Bob, and I've resorted to this cylinder. This will make it particularly easy for us to use the thread tool. So what you can do first is you select a profile, so the edge of your cylinder. I'm going to click right there. And pretty much what you can do is you could set an end condition for that. So you could either choose a certain distance you want to thread your object to, or you could click up to selection. Revolutions works as well, but I prefer up to selection. So what I'm going to do is I'm going to select this face, And as you can see, it's already generated some graphics for our thread, which is pretty cool. So synonymous to our previous tools, what you can do is you can set your sizes. So any size you'd like, it's there. And it gives you multiple options for threading as well. It either gives you the option to cut your thread or extrude your thread. The difference between these two is the fact that when you cut your thread, you're essentially cutting into your cylinder. Meanwhile, if you extrude your thread, what you'll notice is it's actually going to pop outwards. So if I press cut thread instead, and it takes a little while to generate the graphics, boom, you'll notice that it automatically cut it in for us. So you choose the tool that best suits your purposes in that particular case. But usually, at least this is the case for me, but whenever I want to make a quick CAD, I don't usually thread my rods. And mostly because of the fact that they could potentially slow your file down, they could make your application crash. So more or less stick to it for your assignments and whenever it's prescribed. But essentially you can augment all of its different properties here. So you could change the type of thread. Again, since we're using imperial measurements in this file, I'm sticking with the inch die and inch tap options. Furthermore, you could change the rotation angle as well as the angle of your threading as well, the start angle. You could also change the direction of your thread. So you could either start from the right hand or the left hand. Again, this typically depends on what your project requires. It's not something that I can necessarily dictate for you right here. But again, just play around with it a bit and you'll get the hang of it.
So I've gotten rid of our thread, and now what I'm going to show you how to use is the revolved cut tool. So what I'm going to do is I'm going to make a quick sketch on here. So zoom in there, and just a random circle, it's fine. Doesn't need to be too precise. And I'm going to use a midpoint line just to facilitate the speed at which we do this. And trim that, boom. Okay, so our sketch there is complete. And what I want to do is I want to use the revolved cut tool. So since we had the sketch selected, it already knows where to go. So you choose an axis of revolution. I choose this line here. And as you can see, this sphere of influence, what it's going to do is it's going to essentially cut through whatever models are selected. Again, you could also change where you want your end condition to be. It's entirely up to you. But for this case, blind will suffice. So, I accidentally exited out. So we click our axis of revolution and unhighlight our sketch, and it'll be easier to see with a wireframe sketch. So as you can see, what we've done there is we've made a revolved cut right through the middle of this circle. So that's pretty useful. Now I've changed up the sketch patterns and I've added an additional profile on the back here. But before I start with the swept cut tool, I'd just like to point out that there's a bit of a pattern going on here. If you remember the extruded boss tool, its inverted variant was the extruded cut tool. Same thing applies with the revolved boss and the revolved cut. And the same thing will apply with all the three cut tools that we have here. To demonstrate this, what I have is this swept profile. So I've set up the sketch profile and I'm going to add a guide curve, if you remember from before. And I'm going to add all of these additional guide curves too. And if we press OK, you'll notice, boom, what we've done is we've cut a swept cut into our model, just like we did before. If you have guide curves at your disposal, the swept cut tool is good. I've undid the cut, and now you'll notice the lofted cut again. If you have two profiles, one at the beginning and one at your end, this tool is definitely a lot more convenient to use at your disposal, and especially if you have guide curves at your disposal too. So as you'll notice, it'll give us the exact same shape that we had before. Furthermore, the boundary cut follows the same pattern. I'm going to click direction 1, direction 2, and you'll notice if I click this second portion here. It'll do the same thing that the boundary extrusion did for us before. Obviously, I'm not going to generate this. This is not going to work, but it's just to demonstrate that our tools are used in the same way. So the boundary cut will essentially stick to any new directions that you assign it to, and it'll create more complex cuts. And that pretty much wraps up the portion related to cutting. For the next part of the featuring series, I'm going to go over tools like the fillet tool, patterns, mirroring, etc. So stick around and I look forward to see you then.